Okay, now the third question is going to be about the solidification time. So you remember that in the first question, it was about the heat required to do the pouring. The second one was about the time to fill the cavity. And now we want to know what will be the time required for the part to be changed from the solid state to the liquid state. Okay, so let's have a look at the example. In the casting of the steel under certain mold conditions, the mold constant in the Chevronov's rule is known to be equal to 4 minutes per centimeter square, based on a previous experience. The casting is going to be flatted plate, who has a length of 30 centimeters and the width of 10 centimeters, while the thickness is 20 millimeters. With this dimension, I can find the surface area, I can find the volume, right? So determine how long it will take for the casting to solidify. Now again, let's go back to the theory behind that. Okay, so once again, let's study the theory behind the solidification time. So whether casting is going to be pure metal or alloy, solidification will take time. That's concept. And the total solidification time is going to be the time required for the casting to solidify after the pouring. This time is dependent on the size and the shape of the casting, but an empirical relationship known as the Chevronov's rule, which states that the time for the solidification is equal to the Cm multiplied by the V divided by the A up to power n. But the TTS is going to be the total solidification time in minutes. V is the volume of the casting, and this will be in cubic centimeters. A is surface area of the casting in centimeters square, and the n is going to be the exponent, which is usually going to be taken to have the value of 2, and the Cm is going to be the mold constant. So you remember from the question that we had earlier, we can calculate the volume, we can calculate the surface area of the casting, and the n is given as 2, the Cm was given as 4, so we can do the question. But now let's continue to know what the theory behind that. So given that the n is equal to 2, the units of the Cm are going to be in meter per centimeter square, and its value depends on the particular conditions of the casting operation, including the mold material, whether it's going to be made of sand or it's going to be metal. So something like the specific heat and the thermal conductivity are going to be different. Also, the thermal properties of the cast metal, like the heat of fusion, the specific heat, and the thermal conductivity. And finally, the pouring temperature relative to the melting points of the metal. The value of the Cm for a given casting operation can be based on experimental data from the previous operation carried out using the same mold materials, the same metal, and the same pouring temperature, even though that the shape of the part may be acquired different. The Chevronov's rule indicates that the casting with the higher volume to surface area ratio will cool and solidify more slowly than the one with the lower ratio. And this principle is going to be put to good use in the designing of the razor in the mold. Oh, by the way, these are the razors, the green parts we can see, the cylindrical parts we can see in this photo are going to be the razor. These are the probe. Okay, so once again, let's go back to the equation before I get to move to the next page. We can see that this time is going to be increased if the volume is going to be higher, and this time is going to be reduced if the area is going to be higher. So the Chernov rule indicates that the casting with the higher volume to surface area, as we mentioned, is going to be cool and solidify more slowly than the one with the lower ratio, and this principle is put to good use in designing of the razor of the mold, as we mentioned. These are the razors in the mold. To perform its function of the feeding of the molten metal to the main cavity, the metal in the razor must remain in liquid phase longer than the casting. In other words, the time for the solidification in the razor should be exceeding the time for the solidification for the main casting itself. Because the razor is going to be feed the material to substitute the shrinkage in the part. Since the mold conditions for both the razor and the casting are going to be the same, their mold constant will be equal. By designing the razor to have a larger volume to area ratio, we can simply be sure that the main casting solidification first, then that the effects of the shrinkage are going to be minimized. Before considering how the razor might be designed using the Chauvinov's rule, let us consider that the topic of the shrinkage, which is going to be the reason why the razors are going to be needed. So let's go back to the example, and now we can see everything clear for us. First, we have the value for the C. Also, we know the value for the N is 2. We have the length, the width, and the thickness. We can find the volume. And by calculating the faces area and we add them up, we can find the surface area of the block. Now we need to remind how long it's going to take for the casting to solidify. That's my block. Just an example. It's not 2 centimeter high. So anyway, we have that the length is 30 centimeters, the width is 10 centimeters, and the depth is 2 centimeters. We can find its volume. We have the 6 faces, so I can calculate the faces and add them up to find the area. The cm is 4 and the n is 2, so we can simply apply that to calculate the value for the time of the solidification. So the volume is the length times the width times the height, 600 cubic centimeters. The area, we have 2 of each faces. Face 1, face 2, and face 3. So we add them up. 30 times 10, top 1. 30 times 2, this face. And the 10 times 2 is that face. We add them up, then we multiply them by 2. And the area is going to be 760 centimeters square. Finally, we apply the Chauvinov rule, and the time for the solidification can be calculated to be equal to 600 divided by 760, and take it to the power of 2, multiply by 4, and this will be equal to 2.49 minutes. As simple as that. So remember that all the question we're going to have today is going to be a possible question we're going to have in the quiz that starts by the end of this week. Thank you very much for your listening, and see you.